Hello everyone. In this video, we'll cover Boyce Codd Normal Form and also go over the basics of higher order normal forms, that is fourth and fifth level of normalization. Boyce Codd Normal Form is usually referred to as a special case of the third level of normalization, and it is very probable that a table could already be in 3NF, that is, it doesn't have any transitive dependencies but still violate the requirement for a Boyce Codd Normal Form. The rule for a Boyce Codd normal form is that every determinant should be a candidate key. What this means is, in any given functional dependency, the column on the left-hand side should be a part of a key or become the entire key. Like we know, candidate keys are all those columns within a table that have the potential of being selected as a primary key, and normally one of the candidate keys is designated as the primary key. So if we happen to have any kind of a dependency in which a column that is not a part of the primary key is helping us in determining the values of certain other columns from the table, it is considered to be a violation of the Boyce Codd normal form. And that kind of a dependency needs to be removed, and we need to create a separate table for it in order to make it Boyce Codd normal form. For example, consider the table that is given here. We see that there are 4 columns A, B, C, D, and the primary key is a combination of the columns A and B. Also, the list of functional dependencies that hold within this table are given below. The columns A and B together help in determining the rest of columns, that is AB help in determining CD. There is also an additional functional dependence that exists between the columns C and B. What this functional dependence says is, if I happen to know the value of any particular row in column C, it will also help me in knowing or understanding the value in column B. And this particular functional dependence is a violation of the Boyce Codd normal form, since column C doesn't happen to be a part of the primary key. This particular dependence needs to be removed from our given relation in order to make it BCNF compliant. Now, in order to convert the given table into a Boyce Codd normal form, we can rearrange the columns and make a new selection for the primary key. So for example, let us choose a combination of A and C to be the primary key. From the given functional dependence, we already know that if I know the value of C, I also happen to know the value of B. And knowing A and B together already helped me in determining the value of D. Therefore, if we happen to know the values of A and C, it will help us in determining the values of the rest of the columns, that is B and D. Therefore, instead of having A and B as the primary key, we can now have a new primary key as the combination of columns A and C, and the functional dependencies are therefore BCNF compliant, since all the determinants are either the complete key or a part of the key. However, we notice that we have now introduced a new problem. The complete primary key A and C is helping us in determining column D. However, a part of this primary key, that is C, is helping us in determining a column B. So this is classified as a partial dependence, and we know that having partial dependencies violates the rules for second level of normalization. Therefore, in order to convert the form once again back into second level of normalization, we need to remove the partial dependency and create a separate table for it. So now we can restructure our original table into 2 smaller tables. The first table has a combination of columns A and C as the primary key, which together help us in determining D. The next table has C as the primary key, which helps us in determining column B. Now, both of these tables put together do not violate any of the rules for either 2NF or 3NF or BCNF. Therefore, our entire structure is now both at the third level of normalization as well as in Boyce Codd normal form. We'll now very briefly go over the rules that are required for maintaining fourth and fifth levels of normalization. Any table can be said to be in the fourth level of normalization if it doesn't have any multi-valued dependencies. For example, let us consider the following table wherein we have a set of students followed by a list of books that particular student has read, and also a list of languages that each student knows. Now, both of these columns, books read and languages, happen to be multi-valued columns. That is, it is possible that one single student has a huge list of values in the books read column. By capturing all these values together within a single table, like we have done earlier, what it suggests is that this particular student Amrita, from the first row, the way it looks like is that student Amrita has read the book Fountainhead in language English and has read the book Matilda in the language Telugu. While actually there is actually no such association between the two multi-valued columns, that is books read and languages. So in order for this table to be in the fourth level of normalization, what we have to do is separate out these multi-valued columns into separate tables. Now, for example, if we convert that table into two smaller tables, wherein in one table we capture details of students along with the details of the books that they have read, and a separate table in which we have a list of students along with the list of languages that know. Now, these two tables together are not suggesting any kind of information that doesn't actually exist within the original table, and both of these relations put together are in fourth level of normalization. For a table to be in fifth level of normalization, it should follow the property of lossless joins. For example, let us consider this particular table wherein there is a listing of all the companies which sell a particular product, then a list of all the products that are made by that particular company, and a list of all salesmen who work on those particular products. Now, we can actually separate out these two tables into two smaller tables in order to reduce redundancy. What we can do is we can create one single table that stores the details of the companies along with the products that they manufacture, and we could have a separate table in which we list a set of products and the list of salesmen who are involved in selling those products. However, when we try to join both of these tables using the product name column, we notice that we actually generate a lot of spurious data, because this will combine all company names and product names with all salesman names and generate additional data that was not originally found within our original table. Therefore, what we have to keep in mind when we are trying to bring our table into the fifth level of normalization is that the way we decompose our tables or relations should result in lossless joins. That is, there should not be any loss of information, nor should we generate any extra or spurious information that didn't actually exist within our original table.